Hello and welcome to our embedded systems project for this semester. My name is Amr Hisham and I will be introducing you to our device lamfan, and I will be showing you the part that I contributed in. So please come here to our room. This is supposed to be the smart room and it consists of a fan and the lighting system. Here appears as a bulb and the authentication reader. So first of all, I will talk about the light sensor and the light bulb and how it works. So this sensor is a photoresistor sensor that absorbs the light value from the environment as analog value, and then goes to the circuit and changes it to digital using the ADC converter, and then it goes to the light bulb here. The light bulb reads it as digital value. So here is our circuit. Here is the photoresistor. It is connected to both the 5 voltages and to the analog pin over here. And this is our light bulb. Here you can see it here. It consists of 2 pins. The short one is connected to the ground, as we can see here, and also on this here the purple wire. And the other one is connected to the digital pin here that reads after the ADC converts the photoresistor value from analog to digital. So this was my part in the connection. Thank you so much, and now we will talk about the fan part with my colleague Julius.
Hello, my name is Julius, and I will talk about the fan in our lamfan project. The fan consists of 2 components. The first component is servo motor, and the second component is the temperature sensor, and it works as a cooling system in our project. The first component here, the servo motor, acts as our fan, and as we can see it's here, and this is our temperature sensor. Both of them consist of 3 legs. The first leg goes to the ground, as you can see, and the second leg go to the VCC, the positive, and the third leg goes to the digital pin.
Hello, my name is Ahmed Abdurrahman, and I'm here today to discuss the authorization section in the embedded systems project. The authorization section consists of an RFID reader, and the RFID reader has 7 pins. 5 of these pins are connected to the Arduino Uno in the digital pins from 9 to 13, while the other 2 pins are connected, one to the VCC and the other one to the ground. The RFID reader works in 2 methods, by the card or by this chip. This card is supposed to, when it's swiped, to turn off and on the system, while the chip, one works for the temperature sensor and the other one works for the light sensor. Also, they work in the same manner by swiping them in the RFID reader. And now we will discuss the software aspect with my colleague Muhammad Shalabi. Thank you.
Hello, my name is Muhammad Shalabi. I'm going to present the RFID code implementation and the manual delay and why we use the manual delay. So firstly, we have 3 booleans. The first one to turn the system on and off, and then another one to turn the light sensor on and off, and another one to turn the temperature. So firstly, we here we have to check first that if the system is turned on. Okay, we can proceed with checking the light and checking the temperature, as my colleague Ali will present. So firstly, we had to check if the system is true. Then,
taking a closer look, we see that we must initialize the RFID reader first in the setup. And while looping, we have to check for new cards. And when a new card is present, we will get from the content the UID, and if the content UID matches the desired UID, we perform a certain functionality. As for example, this one, if we do contact.substring and we get the desired UID, then we use the card, not the chips, and then we reverse the system on-off boolean, as explained before, so we can turn it on and off.
here we had to check two things. If the lamp boolean is 1 and the temperature boolean is 1. So if it's 1, we can proceed with checking the temperature and checking the light. And afterwards, we initialized here a counter. And why we did that? Because when we used the delay, the automatic delay, that the temperature sensor was catching incorrect numbers. So we had to use a manual delay. So we used a counter, and this counter decrements every time we enter the loop until it reaches 0, and then we reset the counter to change the angle. And now we will proceed with my colleague Ali Kamal, who will present the lamp and the fan sensors.
Hi, so now we're gonna discuss more about how the implementation of the fan and the light was done. So firstly, we initialized the values of the temperature, which is called here temp, and the light pin, and the light sensor pin, and the analog value. So basically, we gave the light pin and the temperature pin, we gave them, we initialized them, assigned them to a digital pin, and then the light sensor pin, we assigned it to an analog pin. As my colleague Amr Hisham firstly said, that the analog pin, the light sensor, reads analog data from the surroundings, and then the Arduino converts it to a digital value, so to be read by the light bulb. That's why we assign the light bulb and the servo motor to digital pins, while the light sensor to analog pins. So that's the initialization here. Then in the loop, we use the analog read function to read the value of the light intensity in the surroundings for the light sensor pin. The same applied to the temperature. Then we converted just the value of the surroundings to be given in Celsius. And then we checked this value, which is the analog value here. If it, the threshold here, as said, it was value of 9. So we checked this value. When we turned off the light, so the light bulb should be turned on now, so that's below the value of 9. That's why we give digital write to the light pin high value, and when it didn't exceed the threshold value, it give it low. Same applied here for the fan. However, we used servo motor as a fan, but the servo motor has a feature which is it can't like turn up until the maximum of 90 degrees, and then it's resetted back to 0 and so on. So if you saw firstly in the demo, it rotated to 90 degrees and then returned back to 0 and so on. So that's basically our code implementation so far. It's very easy. And now with Amr Hisham, my colleague, to wrap up the whole project and tell you more about it.
Okay, so all in all, this is our product, and we hope that you liked it. We think that it will be the future of smart homes, as it can be very helpful in lighting systems and heating systems, along with authorizations, of course. Thank you so much. I'm Amr Hisham. On behalf of our group, we thank you for attending this presentation, and we hope you liked it. Thank you. Bye bye.